Now we're going to take the purchasing of television ads example that we worked and consider a case where we have two objective functions and how can we deal with that. Now let's look at what the two objectives could be. Suppose we want to minimize the cost of advertising and also maximize the amount of exposures that we gain. Okay. Meeting the minimum requirement, but we want to maximize it. We want to minimize cost, we want to maximize the exposures. How can we do that? Well, in linear programming modeling, you can have only one objective function at a given time. You cannot have two at the same time. So one way of dealing with this is to have a limit for one of the two objectives and maximize or minimize the other one. So we're going to look at one such approach here. Now instead of simply saying that we want to meet the minimum requirements, we'll set up a column called excess exposures. Okay. So that would be the difference between that and that. How much are we exceeding the minimum floor? Okay. Note that we are working this problem from the model without the integer constraint. That's what your textbook uses, so I'm using the same example. So we haven't added the int constraint to this solver problem. Now let's copy that. Okay. Now this is the sum of this would be the total additional exposure that we will be gaining. Okay. So now the question is, we want to maximize that and we want to minimize cost. So we'll choose one of the two as the objective, the other as a constraint. So instead of minimizing the total cost, we'll convert that into a budget constraint. So we'll call that budget constraint on total cost. Now we'll insert a row here. Go to insert row and we'll move this title over here. Okay, so this is still total cost, and then we'll have a budget, and initially we will assume that the budget is 2000. So that is given information. Okay, and this is no longer the objective function, so we'll remove the fill color and we want to stay within the budget. Okay. Then the objective we want to maximize, so we'll call that objective to maximize. Okay. And that would be the total excess exposures. Okay. That will be the sum of this column. So let's give a name for this. So we do sum of that. That will give us the total additional exposures, and that's what we want to maximize. So we'll color that like that. So this is total cost. It has the name already. Now let's name this budget. Okay. So now we'll go back into solver. Okay. Now instead of the objective being total cost, change that to total exposures. Did we name that? So let's first name the total exposures. So now let's name total exposures. Okay. Now we have finished modeling. So let's go back to solver. Now instead of minimizing total cost, we'll be maximizing total exposures. Change that to maximize. That's going to be the same. Now, in addition to the minimum exposures that we have to meet, we add one more constraint, and that is the total cost must be less than or equal to budget. Now we solve and we get a new solution. Now at this point, even though we have added this total cost constraint, it still looks like a one objective function problem. Where is the second objective function going to be? How is the second objective function is going to be brought in? And that's where we have to do a sensitivity analysis. So if we run solve a table by varying the budgets and then looking or the maximum exposure is going to be, and now we consider both the concepts in problem solving. So now we have the budget and we'll vary the budget, and for each budget level what is the maximum exposure that we can obtain, and for that we have to run the solver table. So we'll open solver table. Okay, so go to solver table. We'll run solver table. So it's going to be a one-way table. The input is budget. Okay, so we'll call that budget, and we can vary the budget going from say 1800 to a maximum value of 2500 in increments of 50, and our output is going to be how many advertisements we have to purchase, comma, control click the total excess exposures. So now here we have the results. So for each level of the budget, what is the total maximum total exposures possible? And we can change the y-axis from here. So if we select total excess exposure, then we get the graph. As we increase the budget, what is the maximum level of exposures you get? So for any particular level of excess exposure we want, we know that that would be the budget that we have to set. Or looking at it from another way, if this is the level of budget you want to set, that is the maximum exposure that you can derive. Now notice that the first two turn out to be infeasible, not feasible, 1800 and 1850, and that's because we have a minimum exposure requirement. At that budget, solver table is telling us that there is no number of ads purchased will give you that level of exposure. The minimum level of exposures cannot be met if the budget is 1800 or 1850. It has to be at a minimum 1900.